Welcome to the project demonstration of IoT battery management system with active cell balancing and IoT to monitor and log the details of these battery packs. So that is a voltage and SOC, SOH values along with the temperature. So these SOC, SOH values will be monitored and calculated by our microcontroller, that is PIC16F73 microcontroller, which is continuously monitor and calculate the SOH values. And to calculate the SOH values, we need to provide the three parameters, that is the battery levels of voltage along with current and temperature. These three parameters are mainly required to calculate the SOC, SOH values of these respective battery packs. So coming to the ratings, so here we are using the 12 volt to 1 amp batteries. There are three numbers, so which are connected in parallel, and these are getting the voltages to charging from this transformer directly using the switches, that is to charge the battery packs. But in real time, so after we charging the battery packs in fully, then once we switch on the kit, so then the kit itself is a load to this battery pack. So whenever the battery pack 1 voltage is less than the battery pack 2 voltage, then the battery pack 2 voltage will be transferred between these two batteries to level these two battery voltages. For example, so if the battery voltage is 10 volts and this battery voltage is 12 volts, so then the battery pack 2 voltage is greater than the battery 1 voltage, then we need to transfer the voltages from battery pack 2 to battery pack 1 to make these two batteries equal voltage, that is 11 volts 11 volts. That voltage is keep on transferring between these two to make these two batteries level. Same thing will be happen from battery pack 2 to battery pack 3, and again battery pack 1 to battery pack 3. So here the system continuously measuring the individual battery pack voltage and current from these three voltage current sensors continuously by our microcontroller. So then it will check with the voltage differences. So for example, if this battery pack voltage is 12 volts and remaining battery pack voltage is 10 volts, then the system will make this as average voltage to calculate that 10 plus 12 by 3. Then it will get certain value, and after that the so-called value around 10.8 or something voltage should be reached between these two batteries. Till that the system keep on switching these batteries using this electromagnetic relays. That is called the active cell balancing, means transferring voltages from higher end to the lower potential wise. It's calling as a active cell balancing. And coming to the passive cell balancing, it will reduce the voltage by adding the load to the excess voltage to reduce that to the equal voltage to the lesser voltage battery pack. For example, in passive cell balancing, if it is 10 volts, this is 11 volts, then by adding a load to the respective battery pack to reduce the voltage to 10 volts. So means reduction of voltage is a passive cell balancing, and transferring voltage between the battery packs is called the active cell balancing. So this is the main concept to maintain the battery life for in electrical vehicles for maximum lifetime, and that will be achieved by our microcontroller. With the help of this relays, we are going to transferring the voltage between these battery packs, and this is the main application. And continuously the battery voltages along with SOC, SOH and temperature, and also we have the thermal protection also using this temperature sensor. Whenever the temperature exceeds the 45 degrees centigrade, so we set that 45 degrees centigrade. In real time it may be depending on the battery pack. If we use a lithium ion, that would be around 90 degrees, like that. So we can place it for temperature protection, thermal protection purpose. Is a cooling fan was attached to this battery pack, and these are the details will be uploaded to the ThinkSpeak using cloud platform. From anywhere in the world we can access this data. So the field 1 is a battery 1 voltage, battery 2 voltage, battery 3 voltage, and SOCS and SOH values and temperature values. So these can be plotted on this ThinkSpeak cloud platform, and we can access this from anywhere in the world. So to execute these features, nothing but BMS, the battery management system with active cell balancing, as well as the thermal protection and IoT monitoring and alerting, means whenever the temperature increases, fan will get switched on as well as the buzzer will get switched on. So to execute these features, mainly we are making use of these components along with 230 volts power inputs. So here the 230 volts power input is parallelly given as input to the regulator power supply board as well as to the transformer. So this is a regular power supply board will take 230 volts AC input and provide as a 5 volts DC output. So that is the main operating voltage of our electronic components. And parallelly 230 volts input to this step down transformer, which will step down the 230 volts AC to 12 volts of AC, and this 12 volts of AC will be converted into 12 volts of DC, which is operating voltage to our battery pack, means charging voltage, through the switches. And same thing, each and every battery pack will be charged with the help of the switches. So before demonstration, these switches is not a part of the project, and actually these are the switches to charging of the battery pack whenever the battery pack voltage is less, for demonstration purpose. Okay, and next, these batteries are connected in parallel with the help of these relays whenever the battery voltage is less than the other battery pack, to transfer, that means to make a active cell balancing. We are making use of these relays, and these three are the voltage and current sensors, and this one is a buzzer board, and this one is the ESP8266 Wi-Fi module, right. And here is a transistor board which will acting as a switch to control this fan whenever the temperature increases through threshold value, that is 45 degrees centigrade above, then the system will control this fan with help of this transistor board as a thermal protection purpose. So here this one is a microcontroller of PIC16F73, which is the main processing and brain of our system. So before demonstration, first of all, we need to enable the hotspot. Through the hotspot only the system will upload the data to the ThinkSpeak. So for the purpose, we need to configure the hotspot to 7456, okay, without any space, without any capital letter. Password should be 123456789, and AP band should be 2.4 gigahertz. After enabling the hotspot along with data, so right, data and hotspot on the of the Wi-Fi. Now log into the ThinkSpeak cloud platform. Okay, now just on the power supply. After all these setups successfully done, on the power supply to the kit. Right, so welcome to the project will be displayed on the LCD, as well as the voltage will be displayed on this one. So just off this. So all three switches are on, nothing but the battery is charging. Off this. Okay, right. And now wait, here is a battery pack 1 voltage, battery pack 2 voltage, and battery pack 3 voltage, and this one is the SOC value, SOH value, and temperature value here. So you can see the data is uploaded to ThinkSpeak. So here, if you want to get the fresh data, just click on the dot. You can get the date and time along with the data. Now if you want to erase the data, if you want to get the fresh data, there go to the data import export and download the data, so that we can get the data in the backup, means that consists of Excel sheet, and which will show the date and time along with how many samples till now collected. And the field one is a battery 1 voltage, battery 2 voltage, like this. All are downloaded using this one along with the date and time. Now after we took the backup, now go to channel settings to erase the data. To download the data for data import export, and to erase the data, go to channel settings. In that only do clear the channel. So channel got cleared, right. Now go to private view, and we can see the one device connected to your mobile phone, right. Okay, so stay here. The old data got erased here, we can see that. So wait for around 10 to 15 seconds of duration. For every 10 to 15 seconds duration, the data will be uploaded to the ThinkSpeak, right. We got the fresh data over here. So now to make the fault between the battery packs, just we are going to disconnect this voltage input to the voltage sensor, so that the microcontroller assume that the battery, so-called battery pack 3 voltage, is less than the remaining batteries. Then it will be connected between these two batteries. So you can see this. Okay, the voltage is shifting between these two batteries. Okay, and now when the battery voltage is reached, again it's normal. Again this one, you can see this. And when we are disconnecting this, and these two get switched on, as indication of the battery voltage is transmitting and transferring from these batteries to make the battery voltages level. As you can see this, battery 1 voltage is uploading, and battery pack 2 voltage, battery pack 3 voltage, and SOC and SOC, and temperature. So let us check with the thermal protection. So just we are going to increasing the voltage, temperature manually by using any heating object. You can see the fan is off state as of nothing, but it is normal. As you can see, the temperature also increases. So whenever the temperature crosses 45 degrees centigrade, then the fan got switched on, and buzzer will be indicated audible alert, and you can see the alert message on the LCD. You can see the temperature got raised.